front of you. So first, let's start by classifying these examples as either similar, congruent, or neither. All right, so let's start with the red ones. Which description best matches the red ones? All right, those are definitely similar. Good indications, they're obviously not exactly the same, but it looks like their angle measures are the same. The side lengths are different in similar figures, which we just learned. So these ones are similar. I'll just take a second to wake up. Okay, there we go. All right, what about the purple figures? All right, they are congruent because they're exactly the same. Same angle measures and same side lengths. What about down here in green? All right, definitely neither. Their angle measures look different. All right, this one looks like a 90-degree angle. This one is clearly not a 90-degree angle. So that wouldn't fit either category. Good. So we just learned about things that are similar. So here's like quadrilaterals that are similar. And we need to find X and Y for each. So first, are these congruent or similar? All right, these are definitely similar, which means that, yeah, their side lengths are different, but they should still be proportional to each other. So you could set up a proportion. So I could put the smaller rectangle on top and the bottom one, the bigger one on the bottom. And I'm putting the corresponding sides together. So x over 6 equal to 5 over 10 can help me find what the value of x is. All right, we just learned this one. So you set up your proportion, and then what do you do? We cross multiply. So we did 6 times 5, which is 30. Over here, we have x times 10, which is 10x. And now we can properly solve for the x. So like what's opposite of multiplying by 10? All right, dividing by 10. So do that on each side. It'll cancel out on the right side. And what you do on one side, you have to do to the other. So that's how we figured out that x equals 3. All right, so that goes in this first blank. X is 3 feet. What about on the next set? Are those similar or congruent? All right, so since they're congruent, I don't have to set up a proportion. The sides should be exactly the same. So what does x represent? Or what should x measure? 13 inches, which is right here. And then what should y measure to? 7. So the corresponding side lengths are what you are looking at for those. Because again, they are congruent. Questions? All right, so then moving on, we have corresponding angles of similar polygons. We talked about this in the last lesson, so sorry if it's a lot of repeating. But we learned that similar polygons are polygons that have congruent angles. So in these two similar figures, notice the angles are all exactly the same. And then corresponding sides that are proportional to each other. So it doesn't no matter how big I make this triangle, it'll still have the same angle measures as the previous one. But the side lengths will be different. And they're different, but they're proportional to the original. Okay, so corresponding sides of similar polygons. No matter what side AB and A prime and B prime measure, they will have the same ratio to each other. A ratio shows the relative sizes of two or more values and can be written as a fraction with a colon symbol separating the values. And just like how we did in the last lesson, you can see that these corresponding sides do have the same and equal ratios. So like if I take each corresponding side, like 1.8 and I divide it by 2.7, I get a decimal that if I round it, it's about 0.67. The same should happen when I do all the other corresponding sides. So when I do 3.4 divided by its corresponding side on the other triangle, I also get 0.67, and you can check that in your calculator. All right, same with down here. If we do 2.4 divided by 3.6, I also get about 0.67, or 2/3. That's the equivalent fraction stuff. So that's why we're able to set up proportions to solve for missing sides, because since this equals 0.67, I could erase this and put this other fraction, and it would still be true. Questions about that? So then next page. So here's a little bit of practice, but it goes pretty quick, so you can probably answer all of this together. Parallelograms ABCD and EFGH are similar. So the orientation is also what tells you which one corresponds with which one. So like A corresponds with E, the way it's written. That shows that. You can also see it on the picture. B corresponds with F. C corresponds with G. And D corresponds with H. So then which side corresponds to side A? All right, yeah, right? So fill that in. Then what side corresponds with BC? FG. What side corresponds with angle B? Okay, angle H. And then which angle corresponds with angle B? Angle F. And try to use the correct signage, all right, so that we know what you're talking about. All right, questions? All right, so is rectangle ABCD similar to EFGH? So it kind of looks like it, but to know for sure, we have to prove that they are proportional to each other. So if I do my corresponding sides, so if I do 25 over 15, do I get the same thing as when I do 5 over 3? All right, you can test that out in your calculator. You can try simplifying the fractions and see if you get the same fraction. All right, the top one rounds to about 1.67, and the bottom one, is it the same thing? Yes. So are these similar? All right, yes. Also, if you simplify this top fraction, it does simplify to 5/3. Questions? I know this one's a little bit easier. We kind of already covered it. All right, but just making those connections. All right, next one. Trapezoids A, B, C, D, and E, F, G, H are similar. Find the value of X. So this one I'll have you guys try on your own paper. I'll have you practice setting up the proportion so you can try it versus watching me try it. So take like a minute, answer this one. And you could have a proportion that looks a little bit different, but it's still correct. Like you could have done the smaller trapezoid over the bigger trapezoid, like that. All right, no matter what, you still cross multiply and you still get the same equation. As long as you're not mixing up like completely what goes on top, what goes on bottom, it should be all good. Questions about that? All right, so X equals 6, so we set up our proportion, we cross multiply and solve for X. All right, so next one. Dilations and similar polygons. I'll try to just help you with the important stuff here because it is all repeating itself. So triangle has a base of 3 and a height of 4. And it's proportional to this dilated triangle because we know that dilated images are proportional. So it has a base of 6 and a height of 8. So it can be concluded that the original and dilated figure have sides that are proportional, right? Because if I were to put these over each other, 3 over 6 and 4 over 8, they both equal 1/2 or 0.5. So we can conclude that these dilated figures have sides that are proportional. All right, so next slide. Corresponding angles of similar triangles are congruent, and it can be shown by moving the original triangle, so triangle ABC, inside the dilated triangle, and seeing if the angles match and are identical. So if I just translated that first triangle to the right, however many spaces, I think it was 3 spaces that I needed to go, or 1, 2, 3, 4, 5, 6 spaces that I needed to go to the right. And this is the image it creates. So look at the angles. Do they all look exactly the same? All right, so we can visually verify that they have the same measure. And so to summarize, corresponding angles of similar triangles are congruent. All right, you can check it by putting the shape in the other shape. You do have an assignment, this is why. All right, go listen to your notes. It's just a 4-question assignment. All right, it's a 4.02 worksheet that you picked up back here, so there's none left, so you all picked it up. It's a 4.02 practice, and that is all I have to do other than that. So once you finish that, if you want to retake a test or 2, that'd be a good idea, because again, next week is our last week. We've been putting it off. Make sure that we are staying on top of our grade. Questions?